Okay, greetings to you all and welcome to GOE Academy. It's an academy which means God over everything, where we bring success to your doorsteps with ease. Okay, so in today's lesson we're going to be focused on the Faculty of Science, that is Department of Biochemistry, Microbiology, Applied Botany, Applied Zoology, Environmental Science, Geology, and some other departments as well. So our course title for this material is Mathematics of Biologists, and the course code is Maths 2108. It's very important for you to always know your maths, your code, your subject code. Very important. Your course code is very important. Okay, so we're going to look at indices, logarithms, and exponential functions. And our part 1, we're going to be focused on indices. So let's get started with a brief introduction. Now, the short form of writing anything, say a times a times a times a times a times a, observe and see we have 6 a's, is simply as writing it as a raised to the power 6. Now, to better understand this, let's look at the concept of notation. So if you have any number written in the form, say a raised to the power n, that number is said to be in index notation, or we can say index form. So in this case, we have a raised to the power n. N is said to be the index, the power, or the exponent, and a is said to be the base. Let's dive straight into some laws of indices. So the very first law we're going to look at is law of multiplication, which says that if you have a raised to the power m times a raised to the power n, it will be simplified as a raised to the power m plus n. So assuming the bases are the same, a, we just add the powers. So an example, if we actually simplify 2 raised to the power 5 times 2 raised to the power 3, since the bases are the same, 2, we just add the powers. So we just have 2 raised to the power 5 plus 3, which is equal to 2 raised to the power 8. Now let's look at the law of division. If we have a raised to the power m divided by a raised to the power n, since the bases are the same, we just subtract the powers. Are we okay? So let's look at this example. 3 raised to the power 5 divided by 3 raised to the power 2 will simply be 3 raised to the power 5 minus 2, and that gives us 3 raised to the power 3. That's all. Now, very important law, which is the zero law. This occurs when the bases are the same and the powers are the same as well. So you can see we have a raised to the power n divided by a raised to the power n. Since the bases are the same, we just subtract the powers. So we have a raised to the power n minus n. Any number minus itself is always 0. So we'll be left with a raised to the power 0. And this law comprises that, or finalizes that, any number raised to the power 0 is always equal to 1. Are we okay? So that's the zeroth law. So for example, if you have 3 raised to the power 2 divided by 3 raised to the power 2, then it's going to simplify to 3 raised to the power 2 minus 2, which is 3 raised to the power 0, which is equal to 1. Now, any number raised to the power 0 is always equal to 1. Even if you have 1 million raised to the power 0, the value will always be 1. Okay, let's look at the law of further powers. The law of further powers simply says that we have a raised to the power m, or that raised to the power n. It will be simplified as a raised to the power m times n. Let's look at this example. We are asked to simplify this 2 raised to the power 4 or the raised to the power 5. It will just simplify to 2 raised to the power 4 times 5, and that's all. And 4 times 5 is 20, so we end up with 3 raised to the power 20. I guess it's well understood. So let's look at the law of negative exponents. It states that if we have anything, say a raised to the power negative m, it will simply simplify to a1 all over a raised to the power m. So we'll just take the reciprocal 1 all over what we had as our expression, and we change the power, the sign of the power. If it was negative, it now becomes positive. And observe that you can also move from this left hand side back to the right hand side. You can move from this side to this side, as well as you can move from this other side to this other side. So let's take this example. If we are asked to simplify 5 raised to the power negative 4, that will simply be 1 divided by 5 raised to the power 4. That's just how the law works. And let's look at this other example. If we are asked to simplify 1 all over 2 raised to the power 4, that's the reverse. It's just the reverse. We just apply the reverse law. We are just going to have 3 raised to the power minus 4. That's how the law of negative exponents work. So let's look at the law of roots. So the law of roots simply states that if we have a raised to the power n, if you have a number, say a raised to the power 1 on n, as you can see, so you will just simplify to the nth root of a, all of that raised to the power 1. But this is not actually the general form of the law. Let's look at the general form of the law. So generally, if we have a raised to the power m divided by n, then it's going to simplify to the nth root, okay, of a, all of that raised to the power m. This is a general form of the law. So let's look at this example. If we're asked to simplify 25 raised to the power 3 on 2, now this 2 here always mean if we have 2 at the denominator, then we are talking about the square root, okay? And this symbol is the symbol for square root. So you don't need to come and put a 2 here to say it is no. As far as we have 2 at the denominator of our power, we just represent it with this sign. It means the square root. But now when we go to, let's say, 3, 4, 5, that's when we can start putting the numbers here as the cube root or the 4th root, the 5th root. Are we okay? So to simplify this expression, we just have the square root of 25, all of that raised to the power 3. Now 25 can be written as 5 raised to the power 2. So observe and see that this 2 cancels off with the square root sign, and we are left with 5 raised to the power 3, which is just this. So this 5 raised to the power 3, which is the same as 5 times 5 times 5 if you want to further simplify, or 125. So let's look at this second example. If we are asked to simplify 64 raised to the power 2/3, now we have 3 at the denominator. So at this point now we are going to include our 3 here. So that's why we have our 3 here. So we have the cube root of 64, all of that raised to the power 2. Now 64 can be written as 4 raised to the power 3. So that's why this 3 cancels off with the cube root sign, and we are left with just 4. So we have 4 raised to the power 2, and that is 4 squared, which is the same as 4 times 4, which is the same as 16. If that's understood, then let's proceed. So let's look at some equations involving powers, index and exponents. So to solve this type of equations, we just need to take into consideration the following tricks, which are very necessary. So firstly, an equality sign means that the expression on the left hand side is the same as the expression on the right hand side. That's the first concept. And also, if the bases are the same, we simplify and equate the powers, then solve. So if our bases are the same, we just need to simplify, we just need to equate the powers double, and then we solve. Are we okay? Also, we need to take into consideration that if the powers are the same, we can as well equate the bases, and then we solve. So there are cases where the bases will be the same, we equate the powers. There are cases where the powers will be the same, we equate the bases rather, and solve. So let's take a few exercises to better understand this concept. So let's look at the very first exercise. If we are asked to find the value of x in the following expressions, let's take the first example. 2 raised to the power x equals to 2 raised to the power 3. Observe and see that the bases are the same, and since they are the same, we just equate the powers, so x equals to 3. That's all. Second example, if we have 3 raised to the power x equals to 3 raised to the power 5, observe and see that the bases are the same, and since they are the same, we just equate the powers, so our value of x is simply equal to 5. So you see the examples, they are pretty simple, right? Okay, number 3, if we have 5 raised to the power x equals to 1, take note here. 1 can also be written as 5 raised to the power 0, because remember we saw the 0 law, which says anything raised to the power 0 is equal to 1. So 1 can also be written as 5 raised to the power 0, and in that case our expression becomes 5 raised to the power x equals to 5 raised to the power 0. And if you observe keenly, you see that the bases are already the same, so we just equate the powers, so x equals 0. The fourth exercise, if we have 4 raised to the power x equals to 1, we follow the same approach. 1 can be written as 4 raised to the power 0, and our expression becomes 4 raised to the power x equals 4 raised to the power 0, implying that since the bases are the same, our value of x just equals 0. We equate the powers. Okay, example 4, if we have 4 raised to the power x equals to 1, that's still the same exercise. Our value of x will still be equal to 0 since the bases are the same. So example 5, you have 2 raised to the power x equals to 1 on 32. We need to take note that 1 on 32 can also be written as 1 divided by 2 raised to the power 5. That's 2 raised to the power 5 is 2 times 2 times 2 times 2 times 2. That's 5 times. So it gives us 32. And if we look at the law of negative powers, you will see that can be written as 2 raised to the power negative 5. And from there, our expression becomes 2 raised to the power 5 equals 2 raised to the power negative 5. We have succeeded to make the bases to be the same, so we just equate the power. So the value of x will just be equal to negative 5, since the bases are the same. Example 6. So if we were asked to simplify 2 raised to the power x equals 1 on 81, we follow the same approach as the previous exercise. 1 on 81 can be written as 1 all over 3 times 3 times 3 times 3. So 3 has repeated itself 4 times, the law of notation. So that will be just like 1 on 3 raised to the power 4. And from the law of negative powers, 1 on 3 raised to the power 4 is the same as 3 raised to the power minus 4. So our expression now becomes 3 raised to the power x equals 3 raised to the power minus 4. Since 1 on 81 is the same as 3 raised to the power minus 4. So we've succeeded to make the bases to be the same. And in that case, we just equate the powers. So x equals minus 4. Example 7. So if we have an expression, say 10 raised to the power x equals 0.001, and we are asked to find the value of x, it is very simple. Now, firstly, you need to know that 0.001 can be put in standard form as 1.0 times 10 to the power minus 3. How does that come about? Now, it's simple. From the decimal point, you identify a decimal point, you move on till you come across a whole number. So 1, 2, 3. So I've come across a whole number and I've moved 3 times towards the right. So if I'm moving towards the right, my power becomes negative, the number of times I've moved. So I just have this value, which is 1.0 times 10 to the power minus 3. If I moved 5 times, it will be 1.0 times 10 to the power minus 5. That's if I was moving to the right. If I was moving to the left, it will become positive. That's 10 to the power positive 3. If I move 3 times towards the left, it will be 10 to the power negative 3. Sorry, it will be 10 to the power 3 if I was moving towards the left, and 10 to the power negative 3 if I was moving towards the right. So that is the same as 10 to the power negative 3. Now, also, another simple way of doing this is that observe and see that we have moved 3 times towards the right. So this is just the same as 1 divided by 1000. Okay? 1 divided by 1000. And 1 divided by 1000, you know, is the same as 1 divided by 10 raised to the power 3, right? 10 raised to the power 3. And if you observe and see that from the law of negative powers, if you simplify this, it takes you to this. Are we okay? It takes you to that. So all the same. So let's proceed. So this implies that 10 raised to the power x will be equal to 10 raised to the power minus 3. And since the bases are the same, we just equate our powers and our value of x equals negative 3. Example 8. If we have 10 raised to the power minus x equals 0.0001, we follow the same approach. So if we simplify that, we are going to end up with 1.0 times 10 to the power minus 6, since we have moved 6 times to arrive at the whole number position. We have moved 6 times, 1, 2, 3, 4, 5, 6. And we're moving towards the right, so our power is negative. Okay, so in that case, 10 raised to the power minus x equals 10 raised to the power minus 6. The bases are the same, so we equate the powers as usual. So negative x equals negative 6. Be careful here. We are asked to find the values of x and not the values of negative x. So at this level, we need to divide both sides of the equation by negative 1 so as to make x the subject of the formula. And at that level, you see that the value of x, since negative cancels negative, negative cancels negative, so you just observe and see that the value of x will just be equal to 6. Example 9. If we have 2 raised to the power x equals to 0.25, observe and see that 0.25 can be written as 25 divided by 100. So we just move from here, we move 1, 2 until we get the whole number portion. So this is just like 25.0. Okay, 25.0 times 10 to the power minus 2, since we have moved 2 times towards the right. Or it can be written as 25 divided by 100, and it is the same as 1/4. Now, applying laws of indices, you need to know that 1/4 can also be written as 1/2 times 2, which is the same as 1/2 squared. Negative law, negative exponent, that's the same as 2 raised to the power minus 2. So at this level, you observe and say the bases are the same. We equate the powers, and our value of x equals -2. Okay. Example 10, if we have 5 raised to the power x equals 25, you need to recall that 25 can be expressed in index form as 5 times 5, which is the same as 5 squared, as we saw initially. So in that case, you see 5 raised to the power x equals to 5 squared, and since the bases are the same as usual, we therefore equate the powers. So x equals 2. Exercise 11, we have 3 raised to the power x equals 27. Recall that 27 can be written as 3 times 3 times 3, which is 3 raised to the power 3, since 3 has repeated itself twice. That's the laws of notations, as we saw initially. So in that case, our expression becomes this, and since the bases are the same, we just equate the powers. So our value of x equals 3, pardon me. Okay, exercise 12. If we have x squared equals to 3 raised to the power 2, this is a trickish example. Observe keenly and see that the powers are the same, 2, 2. So all we need to do here is to equate the bases. So equating the bases, we have x equals to 3. That's all. Example 30. If we have 3x minus 1 all that raised to the power minus 1 equals to a half. If we have to find the value of x, we begin by, you need to know that a half is the same as 2 raised to the power minus 1 from the law of index, from the law of negative powers. And to that effect, 3x minus 1 all that raised to the power minus 1 will be equal to 2 raised to the power minus 1. You need to observe keenly and say that our powers are the same, and since the powers are the same, we just need to equate our bases. So we have 3x minus 1 equals 2 raised to the power minus 1. Sorry, since we are equating the bases, we have 3x minus 1 equals to 2. We are equating just the bases. And observe and see that this is a linear equation, and to solve a linear equation, what we want to do is just make x the subject of the formula. So the first thing that the steps is -1, so we need to cross it. It needs to cross the equality sign, and whenever something is crossing an equality sign, the sign changes. If it was negative, it becomes positive. That's why since -1 has crossed, it now becomes +1. So we have 3x equals to 2 plus 1. 2 plus 1 is 3, so 3x equals to 3. And at this level, we need to divide both sides of the equation by 3 to make x the subject of the formula. So dividing that, we all see that even a Form 1 child or a Class 6 child or a Class 1 child knows that 3 we go off with 3 and 3 we go off with 3. So on the left hand side, what we are left with is x, and here we are left with 1. So you should be able to see that the value of x will simply be equal to 1. Example 14. If we have 2 raised to the power x plus 3 equals to 16. Now to solve this, we begin by bringing 16 to the base of 2, since on the left hand side our base is 2. So to do this, you need to know that 16 is the same as 2 times 2 times 2 times 2. 2 has repeated itself 4 times, so from notation that means 16 is referred to as 2 raised to the power 4. So in that case, our expression becomes 3 raised to the power x plus 3 to be equal to 2 raised to the power 4. And since the bases are the same, we can now equate our powers. So x plus 3 equals to 4, still a linear equation. To make x the subject of the formula, we send anything that does not have x to the other side of the equation. So 3 does not have x, so we send it to the other side. So it becomes x equals to 4 minus 3. So the sign has to change since it has crossed the equality sign. 4 minus 3 is simply 1, so the value of x equals to 1. Great. So let's look at some equations involving powers. Let's look at these examples. These are just basic examples. 3 raised to the power 5 is the same as 243. 243 is the same as 3 times 3 times 3 times 3 times 3. That's 5 times 3 is the same as 3 raised to the power 5. So these are just exercises to show you that the left hand side is always equal to the right hand side. So if we have 3 raised to the power minus 3, it is the same as 1 all over 27, the law of negative powers. And 27 is the same as 3 raised to the power 3, so we have 1 on 3 raised to the power 3. From the law of negative powers, that's the same as 3 raised to the power minus 3. We have 4 raised to the power minus 4. That's the same as from the law of negative powers. We have 1 on 256. And 256 is the same as 4 raised to the power 4. That's 4 times 4 times 4 times 4. And it's the same as 3 raised to the power minus 4 from the law of negative powers. So you see, it's more of repetition. It is more of repetition. All what you need to know is the laws and how to apply them. So let's look at the next phase of our video, part 2, which is logarithms. So let's look at the laws of logarithms. So the very first law we're going to look at is the law of multiplication. So the law of multiplication states that if I have the log of a times b, then it's simply going to simplify to the log of a plus the log of b. So let's look at this example for better understanding. If we have log of 3 times 4, then we simply have the log of 3 plus the log of 4. That's all. Law 2, we have the law of division. If we have log a divided by log a divided by b, it's simply going to simplify to the log of a minus the log of b. For example, you have log of 7 on 5, it's simply going to simplify to the log of 7 minus the log of 5. You see, they are pretty simple exercises, right? Let's look at law 3. Law 3 says we have something in the form the log of a raised to the power n, where n is the power or the index. Then it's simply going to simplify to n log a. We simply bring down the power in front of the log. E.g., we have the log of 25. You know, it's going to be simplified as a log of 5 squared. 25 is the same as 5 raised to the power 2. And we simply bring the power, which is 2, in front of the log. So we simplify to 2 log 5. That's all. Law 4, if we have the log of a raised to the, if you have the log of a base a equal to 1, observe and see that we have the log of something to the base of that same thing. So it's simply going to simplify to 1. Okay, so for example, if we have the log of 5 base 5, note that it is going to simplify to 1. If we have the log, if we have the log of 8 base 8, it's going to simplify to 1, right? So that's it. So we proceed with our lesson. So we look at the relationships now between log and indices. Now note that there are some other laws too, very important laws too, but these are the main laws you need to know for now, for your level. Okay, let's look at the relationship between log and indices. If I have an expression, say log of a base b equals to c, and I want to transpose this from logarithms to indices, I want to convert this logarithmic function into an index function. I simply need to take b, take note the base raised to the power the answer, which is c, to be equal to a. I hope we all are good up to this phase of the lesson. Okay, so let's look at some examples for better understanding. So if we are given the log of 49 base 7 to be equals to 2, you should observe and see that 49 will simply be equal to 7 raised to the power 2, or 7 raised to the power 2 will be equals to 49. 7 raised to the power 2 is the same as 7 times 7, which is the same as 49. So 49 equals 49. So we have the log of 1 on 4 to the base of a half to be equals to 2. Then it is simple. We just have 1 on 4 to be equal to, we just have 1 on 4 to be equals to a half raised to the power 2. A half raised to the power 2 means we just need to take a half raised to the power 2 simply means we just take 1 squared divided by 2 squared. And you know that 1 squared is 1. That's why we have 1 here. And 2 squared is 4. So we have 4 here. So that's the same as 1 on 4. And 1 on 4 is the same as 1 over 2 times 2, which is 1 on 4. So the same thing. Example 3, if we have the log of 1 base 5 equals to 0, then you observe and see that 1 is equal to 5 to the power 0. And from the zero law of indices, we see that 5, anything raised to the power 0 is always equal to 1. So 1 equals to 1. Okay. If we have log 0.01 base 10 equals to negative 2 as our next example, this is a simple example. All we need to know is that from the previous examples, we know that 0.01 can be simplified as 1 all over 100. since we have moved 2 times to the right, in order to arrive at the whole number position. So we have 1.0 times 10 to the power minus 2, which is same as 10 to the power minus 2, or you can simplify it in this form: 1 on 100. 100 is 10 to the power minus 2, which is the same as, from the law of negative powers, 10 to the power minus 2. So that implies that log of 10 to the power minus 2 base 10 will be equals to minus 2. And you should be able to see that 10 to the power minus 2 equals 10 to the power minus 2. And that's it. So let's proceed. Now let's look at these other trickish examples. Find the values of x in the following. So if we are given log 32 base x equals to 5, we apply the same change of log to index form. So you should see that 32 equals x to the power 5. So at this level, we need to bring 32. We all know that 32 can be written as 2 raised to the power 5, right? So at this level, you should see that the powers are the same, 5, 5. So we equate the bases. So you should see that the answer, the value of x, will just be equal to 2. Example 2, if we have log x raised to the power 5 is 5 to be equals to 0. We apply the same principle. You see x raised to the power 5 equals 5 raised to the power 0. And you know anything raised to the power 0 always equal to 1. And so our value of x will simply be equals to the 5th root of 1. The 5th root of 1 simply means 1. Means we should look for a number that will multiply by 1 times 1, will multiply by 1 5 times. So it's going to give us that same number. So we have 1 times 1 times 1 times 1. 5 times it gives us 1. So the 5th root of 1 is simply 1. By right, normally I was supposed to have, for that simplification, I was supposed to have this to be equal to the 5th root of 1 raised to the power 5, so that this 5 simply cancels off with the 5th root, and we are left with 1. So that's why the 5th root of 1 is 1. So our value of x is simply 1. So let's look at the next phase of the example. If we have the log of x squared plus 6x plus 11 base 4 to be equals to a half, we apply the same principle, and we see that x squared plus 6x plus 11 will simply be equal to 4 raised to the power half. So 4 raised to the power half simply means you take the square root of 4. And you know 4 is the same as 2 raised to the power 2, so that 2 actually cancel off with the square root sign, and we'll be left with 2. So the square root of 4 is 2, right? So we're going to be left with x squared plus 6x plus 11 to be equal to 2. And at this level, I'm seeing it to look like a quadratic equation, so I need to simplify. So I need to end up with 0 on the right hand side. So I send 2 to the left hand side, and since it's crossing an equality sign, the sign has to change from positive to negative. So we are going to have 11 minus 2, which is, to simplify like terms, 11 minus 2 is 9, so we have x squared plus 6x plus 9 equals 0. So we can solve this quadratic equation. You see, this looks like a quadratic equation. We can solve it using the formula method, the completing the square method, the factorization method, the graphical method, and other methods too. But in this video, I will use just the formula method. Maybe if we come across another exercise, I will use the factorization method. But you can check our other videos on Geo Academy. Just go to Google, type Geo Academy, or you can go to YouTube. You will see some of our videos on solving quadratic equations using all the other methods. So in this lesson, in this video, since it was not our focus, I will not actually explain it detailedly. You can go to our channel and check out the videos. Please, if you're watching these videos and you haven't subscribed yet, I'll urge you to do so, so that when we upload our forward videos, you'll be able to be notified. Thank you. Okay, let's proceed with our lesson. Now, a quadratic equation is an equation of the form ax squared plus bx plus c equals to 0. Now, so to solve a quadratic equation, we always generally use this formula, which is called the formula method. X equals negative b plus or minus the square root of b squared minus 4ac. Please, this means plus or minus, okay? So take note of that. So square root b squared minus 4ac. This b square root of b squared minus 4ac is also called a b squared minus 4ac is also called a discriminant. So all of that divided by 2a. So if we compare this general form of a quadratic equation. If we compare this general form with this, our quadratic equation, you will see that the value of A is simply that number that is in front of x squared, which is 1. The value of B is that number that is in front of x, which is 6, and the value of C is simply a constant number, which is 9. So with that being said and done, we just need to substitute in our formula and we simplify. So I've just replaced B in its position, E in its position, and C in its position. So if I simplify that, 6 squared is 36, so I have the square of 36 minus 4 times 1 times 9 is 36, so 36 minus 36, that should give us the square of 0. So I have negative 6 plus or minus the square of 0 divided by 2. Note that the square of 0 is simply 0. Okay, so x will simply be negative 6 plus or minus 0 divided by 2. So at this level, we need to separate our solutions. At this level, we need to separate our solutions. So we're going to have two solutions. Since the quadratic equations, we need to end up with two solutions. Okay, so we're going to, the first part of our solution will be the positive part. Remember, I said I identify something as plus or minus. This means plus or minus. So we need to work in the two cases. So first of all, work in the positive case. This is it. That's the positive case, and later on the or part is the second case, which is the negative part. So that's it. So we have two solutions. And if we further simplify, negative 6 plus 0, anything plus 0 is the same thing. So negative 6 divided by 2 should give us negative 3. So you see that the value of x will be equal to negative 3, or on the other side it will still be negative 3. So these are double roots. We have double roots in this case. Okay, so find the values of x in the following. So we have 5 raised to the power 2x minus 26 into 5 raised to the power x plus 25 equals to 0. This is a typical A-level question, but I'll make it simple for you. Now 5 raised to the power 2x is the same as 5 raised to the power x times 2. Okay, that's from the law of other powers. You should know that. We saw it already. So this is the same thing. So at this point, we need to let 5 raised to the power x to be equal to m, or you can let it to be equal to y, to be equals to p, q, or whatever constant or variable you want it to be. So let's substitute. Anywhere we see 5 raised to the power x, we replace it with m. So we will have m squared minus 26 m plus 25 to be equal to 0. So observe and say that this also resembles a quadratic equation. Now here I would love to use the factorization method to be fast, but like I said, you can go to Google or YouTube and go into our channel, chip in some of our videos. You'll see some videos on solving quadratic equations using all the other methods, which are detailedly explained. Here I will not detailedly explain since it was not our point of focus. So the first thing to solve a quadratic equation is for me to identify my AC. My AC is, my value of A is 1. Okay, my value of A is 1, my value of C is 25. So AC is 1 times 25. My value of AC is 25. So I just need to look for the factors of 25. The factors of 25, that when I multiply, it should give me the value of AC, which is 25, and when I add, it should give me the value of B. The value of B is simply what? Negative 26. Okay, from the general form of a quadratic equation is 26. It's negative 26. So those two numbers, those that are found in the factors of 25, can be negative 25. I can think of negative 25, and I can think of negative 1. So remember, when you're taking the factors of AC, you're taking both positive and negative factors. Be careful, okay? Because some of you will be wondering that is negative 25 a factor of 25? Take note, you're taking both positive and negative factors. So the two factors, remember, now if I take negative 25 times negative 1, you see it gives me what? 25. So that's okay. Now if I add these two factors, it should also give me the value of B, and negative 25 plus negative 1 should give me what? Negative 26. So it gives me negative 26. So the factors are m minus 25 and m minus 1. So I need to put in this form. So I have m minus 25 into m minus 1. All of that should be equal to 0. And if I saw, you see that m will be equals to 25, or let me just say I'll have m, I need to equate each of them to 0, so I have m minus 25 to be equal to 0, and from here you see that the value of m will simply, you cross 25 on the negative 25 on the other side of the equation, and since it's crossing the sign, it changes from negative to positive, so m will be equals to 25. And same thing on this other side, if you equate m minus 1 to 0, you see that m will simply be equals to 1. Like I said, you can check on our other videos for better explanations on solving quadratic equations, detailed explanations. Okay, so you see m equals 25 or m equals 1. But remember that we had let initially we had let our m to be equals to 5 raised to the power x, right? Initially, take note. That's why we let initially. So we need to consider it. We are looking for the values of x and not the values of m. So 5 raised to the power x is equals to m. We have our values of m. So we need to, so from here you see that 5 raised to the power x will be equals to 25. And to simplify this, we need to take log on both sides. This is another case where we need to apply the laws of logarithms. So if you take log on both sides, we are going to have log 5 raised to the power x will be equals to log 25. Now you need to see that this first part has to do with the other law of logarithm. We saw that you just bring this power, this index, in front of the log, so it becomes a force in here. And you should be able to see that log 25 can also be simplified as log 5 squared, right? Log 25 can also be simplified as log 5 squared. Or let's just chill down for now. Now to make x the subject of the formula, we need to divide both sides by log 5, right? And if we divide both sides by log 5, you should see that we're going to have log 25 divided by log 5 as our value of x, right? And log 25 can be written as log 5 squared. So we have log 5 squared divided by log 5. So this is the same as 2 log 5. We bring down the power in front of the log, that's it here, and divided by our log 5. Now you should be able to see that log 5 is going to cancel out with log 5, and we end up with 2. So log 5 divided by log 5 is 1. So 2 times 1 is 2. So that is our answer for the first part. So also, we also had our value of m to be equals to 1. So, and 5 raised to the power x equals to m. So we also have 5 raised to the power x to be equals to 1. And note that 5 raised to the power 0 is equals to 1. From the previous examples we've been solving, anything raised to the power 0, is always equal to 1. So this can be written as 5 raised to the power x equals to 5 raised to the power 0. And since the bases are the same, we just equate the powers. So hence the values of x, our value of x will be 2 or 0. Okay, we have come to the end of our lesson. I just want to thank you all for watching the video. And to this effect, please, I would like you all to kindly subscribe to our channel, to support us by subscribing to our channel, so that whenever we drop in videos, you will be automatically alert. Okay, and also please, I would love you to like, comment, and share. Drop your comments in the comment box below, so that we can attend to them. If it's a question, if it's a modification, if it's a contribution, I would love you to drop it so that it will be of help. Thank you so much for watching, and stay tuned.